Afternoon. Thanks for sticking around. 4 o'clock in the afternoon. Tough session. How many of you are in the electric power business or serve that business? Okay, so a little bit less than half. Probably the most mature efforts in our business in this space is in generation. I work in the transmission part of AEP, so I'm going to give you a slightly different perspective. First, a little bit about AEP. We have divested of some significant generation assets and retired quite a bit as well due to some of the environmental requirements. We still have 32 gigawatts of generation available. We consider ourselves the largest transmission owner in the U.S. with about 40,000 miles of transmission lines. In the transmission business, we also take care of the distribution substations as well as our transmission substations, and there's about 3,500 of those substations on the AEP system. So very distributed set of resources, quite different than concentrated plants where you have a little bit of an advantage because you have a staff there. You can attend to things a little bit more immediately. When you're distributed across 13 states and 3,500 substations, some of them quite remote from your service centers, it takes a long time to get to those assets. So we have a different kind of rationale. In generation, those assets are critical to the cash register of the company. And it's important that they keep them operating, and they can't afford those things that Bernie talked about where you damage a plant for extended periods of time. On our end, in the transmission part of the business, we're networked, so we can actually afford to lose that asset. A different kind of animal. In the distribution substations, however, we're generally not redundant. So if you lose some of those assets, then customers are out of service. Again, you have a remote situation. It takes a long time to restore that service. And so anyway, we're across 13 states. If you count them, they're all contiguous, and we actually connect between Canada and Mexico and the Atlantic Ocean and the Gulf of Mexico. Our system isn't necessarily contiguous, but the states in which we serve, they are. We serve about 10% of the load in the Eastern interconnection, and we serve about 11% in ERCOT. We don't have any assets presently in the Western interconnection in the U.S. We have the privilege of serving in 4 different regional transmission organizations and 4 different ways of doing things there. We've got a 100-plus year history of being a low-cost provider and having a reputation for innovation. So some of the challenges, I alluded to some of them already. I think one of the key things for our assets is the nature of them being distributed in so many places. So it's really important that we have better awareness so we can predict or eventually, as Ralph talked about, prescribe based upon the information we have what is going on with those assets and what we ought to do about it. Something that we're not going to talk about so much today in this presentation, but system awareness is a critical thing to us. As the transmission operator, we have a transmission operations center, and their awareness of the system has served us well. However, the world's changing in terms of the kind of generation that's on the system, the way it behaves, the uncertainty around it being available, and the significant changes that can occur cause the awareness of that system to need to be faster in its assessment than it has traditionally been. So there'll be a big challenge in that space. I'm not going to talk any further about that in this presentation. I'm going to focus more on not the system, but the assets which make up that system. Our awareness of the condition is inspected in, for the most part, like many other utilities of our nature in transmission and distribution. And so it's a kind of random sampling of the condition based upon past experience of where do we expect a gasket to be going bad or where do we expect another problem to be happening. And so it's guesswork. And one of the key challenges we have is that the transmission assets at AEP are growing pretty rapidly, and the O&M budget isn't. So you have to figure out how to stretch those maintenance dollars over more and more assets. And those assets, other than the ones being added, are aging. They're probably getting close to the end of their useful life. We'll have to replace a lot of them. How do you make that decision? How do you justify what looks like maybe $1 billion a year in replacing of transmission and substation related assets to a regulator or the respective regulators in all those states? So you need some kind of better criteria than age alone for why I'm replacing those assets. And frankly, you couldn't come up with enough money to do it all based upon age. So you need to prioritize that. The challenge is also there in terms of how do you manage the data. We do have what I'll call historians for SCADA information, supervisory control and data acquisition information that comes into our operation centers. That's very basic analog volts and amps and that kind of thing. And then we have the inspection data that we record in our own version of a historian. What we don't have a lot of are the real-time monitoring, and that's a key thing that we're changing at AEP. There was a lack of really a commercially available system to do this for us readily. So I'll tell you a little bit about how we came upon the solution that we had. As we're doing more capital work, there's a huge pressure on getting the outages to enable us to cut in those new facilities. And with the advent of regional transmission organizations, you need a lot more notice to be allowed to take those outages. So there's a big pressure on how to get those outages done. So if you're asking for a maintenance outage because of a scheduled routine inspection, you might not get that because of the outage constraints that exist. And so that's very wasteful of your resources. You could literally drive out to that remote facility, ask to go ahead and switch it out, and they say, well, nope, situations change, can't do it today. So outage management's a big challenge. And of course, the public has rising expectations on reliability, resiliency, and relationships, as I call it. They want to be better informed about what's going on. FERC Order 1000 has introduced competition to us in terms of owning new transmission assets. So we've got to be cost conscious. And then there's rising expectations for the resiliency of the grid. Inspector Gadget, well, like Bernie, I'm in my 34th year, Bernie, and from about the time I started, we've been talking about condition-based maintenance and predictive maintenance, and we've been talking and talking and talking. What I'm excited about is we finally stopped just talking about it, and like you, we're moving forward. And I think being on that march makes all the difference. And it's going to make all the difference also to those who provide services and products to us. If they see we're committed to do this, then I think that industry will recognize they can actually innovate and build those monitors and sensors and transducers that are going to help us to detect what we need to detect. In the past, a lot of the things we got were, I'll say, supply-driven rather than demand-driven. We got things that people could do and could sell to us. We got lots of things that I call the Inspector Gadget solution, where it was everything in a box on the side of my transformer or breaker. It significantly changed the center of gravity of the device. It was so big. And 3,500 locations, if you tried to multiply that out, and you had software to update at 3,500 places and had to send people out there to do it, not going to happen. So it's not a very good model that we had in the past. The other part is you're putting these devices on so that you maintain the equipment when it needs it. It raises its hand and says, okay, I'm in distress, I'm ill, please attend to me. Or it's not raising its hand, leave me alone, because if you touch me, you might actually inflict harm. But we found ourselves out maintaining the devices that were keeping us from maintaining the device, that were supposed to keep us from maintaining the devices. So that obviously does harm, and that is not a sustainable model. So a lot of people got frustrated with this over the last 30-some years and kind of gave up and said it's just not going to work. But I think a lot has changed that allows us to have a better crack at it this time around. I think the other part was software and firmware were constantly problems. And what they tended to do is dump a bunch of data into what I call a data dumpster. And so our subject matter experts had to do dumpster diving to figure out, what was their meal for the day? How do I deduce what's going on? How do I prioritize where I spend my attention? We need to solve that problem. That's a challenge. We need to put on their desk the portfolio of things they need to know and attend to today so that they prioritize their effort and use their expertise for something better than sorting the data. Okay, in the upper right corner, I'm trying to show, this is the failure rate for EHV, or extra high voltage transformers, really large transformers in the blue shadow. And then the red graph is an approximation of what we anticipate to be failure rates. As those assets age, they're moving toward that red line, and the multiple of population times that probability of failure is going to mean we're going to have a lot of trouble. But again, what do I do? Do I go out and inspect those more frequently with that small O&M budget I have? Not really practical. Do I let it fail and cause some of these celebrated on the 5 o'clock news events? Probably not a good idea either. So I better come up with a new way of doing that. The purpose of the Asset Health Center that we have developed is 3 things. Number 1, to prevent failures wherever possible. We won't prevent them all, but prevent as many as you can, especially avoid surprises. Secondly, it's to optimize the maintenance, do the right maintenance at the right time in the right place with the right people. Know in advance before you go to the site what work you need to do. And then thirdly, as we have this aging infrastructure and we need to do all of this replacement, we need to have a good justification and rationale and criteria for how we will replace that portfolio of assets over time. What comes first? So those are the 3 intentions of the Asset Health Center. Our assets are pretty old. About 1/3 of our transformers are more than 50 years old, and almost 1 in 5 are more than 60. Breakers are not quite as old because the technology has changed quite a lot, and some of them have been changed out due to that reason. Transmission lines aren't on the list, but eventually we'll get there, and we would like to include them in our monitoring as well. Right now, transformers, circuit breakers, and station batteries are what are included in the Asset Health Center. We do see that a lot of advancements have been made in technology, and so those advancements in IT and operational technologies and somewhat in the sensors have enabled us to do a lot better than we did 34 years ago when we first started trying to do this. In terms of implementation, we just finished the implementation of the platform last December, 2015. We did it in 4 phases. We actually had useful product along the way, so we were getting some help as we developed it. I mentioned that it covers the substation equipment. We have standardized packages that we're putting on all new equipment that we're buying. And then we also have standardized packages when we're retrofitting existing assets. Even though they're networked, as I mentioned, we're starting from the largest assets, the extra high voltage assets first, the bulk transmission system, in part because it's easiest to justify. That's the biggest cost asset. And so as we're developing it, we want to try to cover the most expensive assets first, help that technology improve, and get the cost down and hone the packages a bit better before we get to the distribution substation equipment, where the cost of the asset is less and the appetite for spending a lot of money on monitoring is going to be a little bit less. We do, as I mentioned, intend to go to other assets in the substation eventually as we perfect the system, and we'll also try to start incorporating the line assets. So there are 4 basic elements to what we're doing. We're collecting and organizing the information. We're using some decision engines, I'll show you an illustration in the next slide, to try to predict the risk of failure and the remaining life of the equipment. Where there are alerts, rapid trends that are changing, we try to inform the necessary parties. We also are able to inform them about comparisons between assets in the same design family or between families because sometimes those differences can really help you make the right decisions. And then, of course, to act, to come up with the right process, the actionable intelligence that Bernie talked about related to the equipment. It's, I think, a little bit more challenging in the substation space. I think the maturity of looking at rotating machines and the monitoring that has been done there is ahead of the game in terms of what we have with power transformers, which are kind of customized devices. Breakers a little bit easier. And substation batteries are just so inexpensive, it's hard to come up with an inexpensive monitor that it isn't as costly as the battery you're trying to monitor. That, by the way, on the batteries is a compliance issue. After the major Northeast blackout that we had in the early 2000s, a lot of the standards that were previously voluntary became mandatory, and there were penalties attached. If you violate one of those standards, you're subject to a fine of $1 million a day per event. That can add up real quickly if you're found in violation. So there are increasing number of standards that are pressing upon us. That's why we're monitoring the batteries, because you have to monitor them. I mean, you have to inspect them under a certain periodicity. You have to do what you say, and sometimes people forget, or a storm happened, you know, a day before you were scheduled to go out and do that one in time. You missed it, and then you're subject to a fine no matter what. You just didn't do it when you said you would. So the next slide attempts to show a little bit what's going on. We've got several inputs into the Asset Health Center that are providing data at different rates. That information is coming from offline databases, such as the inspection data that we get from people who actually still go out and do the inspections or maintenance that's performed. The offline database also contains the essential identification and rating information for the equipment as part of the and baseline information on its age, its current condition, etc. SCADA is what the operations people are looking at, the essential data on voltages, currents, loads. The online sensors are the quantum leap that we're trying to make. Even if you don't have the online sensors, just organizing and arranging the offline data together with the SCADA data can be immensely helpful. It takes work off the plate of your subject matter experts to organize and evaluate and assess. You can apply basic decision engines to that stuff and, again, give them information that they don't have to go compute themselves. So you make them more effective. But the online sensors is a quantum leap, and that's where we're really trying to make some significant strides forward. That information's all fed into the performance models. We have the option with the Asset Health Center of using the default algorithms, which are algorithms developed with ABB Ventix through their extensive experience as a leading supplier of equipment. We had some influence on those as well because we kind of developed this along with them. But we have the option of pulling out that model and plugging in a different one if we should so desire. So there's a modularity to this that's really important. From this, all the computations occur, and the reports, recommended actions, alerts, and updated risks of failure are produced as a result of it. And that can all be visualized through interface with the Asset Health Center. Okay, one of the other things is you have to know the root causes of your failures and monitor what matters most. Sometimes I think, like Bernie said, you're monitoring things you had no idea that they were meaningful. I think it's okay for us to do that, but one thing we want to do is make sure for extra high voltage transformers we're monitoring the kinds of things that lead to their failure or degradation. That's a different set of things than it is for a distribution substation transformer. The way they fail is different. The causes of failure are different. And so it's important that you monitor them differently and appropriately for those failure modes, and then similarly for circuit breakers. So I'm not going to go through all the details of the specifics, but you tailor that for the particular category of equipment that you're looking at. And the benefits then are, for the operations people, you have a lot more information about how to anticipate trouble. And if you have contingencies that occur, It enables you as an operator to have an idea whether the assets that are being now more heavily stressed because of those contingencies are something that you can live with or not. So it helps inform the operator a lot more to avoid surprises. I think also for operations, it helps you be aware of just the condition in general of that equipment, so that if you have other outages being requested, you have kind of a sense that, yeah, that's going to be okay, or no, that's not going to be okay, and why. For maintenance, it helps you focus your resources on the right assets at the right time. And for asset planning, for the folks looking at the replacement, obviously it gives them the prioritization that they need and the justifications that they need. For the enterprise, that helps you reduce your risks to the public, to your employees. There's a safety implication. We actually have some cases where we had workers in a substation that could have been hurt if you didn't have some information about the condition of that asset. And if they happened to be on lunch when an explosive failure occurred, they were working right around the transformer, and we were lucky. We went back, and this was before the Asset Health Center was fully operational. We went back and looked at the data, and it looks like we probably could have predicted that that was going to happen, but we weren't up and running yet. Wouldn't that be an interesting situation, to have a fatality or an injury, and you were that close to having that information? So safety is an implication as well. If a crew is going to go to a substation, it's helpful that they know what is the state of those assets that I'm about to go approach. We think that that's an important thing for zero harm. It's also helping you avoid collateral damage. You know, when you have one fail, like Bernie talked about, you can have the ones next to it be damaged as well. You take out a whole array of generator transformers, you damage parts of the plant building itself, and of course you can also damage things inside. In our case, in the substations, there's a little bit more space, a little bit less likelihood, but we've had consequential damage to adjacent assets as well. And then finally, you know, when these things happen, it doesn't do any good to your reputation or credibility. So that's an important enterprise benefit. A couple things we've learned fairly early on. We've had this in place now in phases over the last couple of years. I mentioned one of the violent failures. We've got a couple of 765,000 volt system of transformers that failed, and we saw probably 8 to 10 hours of information before that failure. No indication from other parts of the monitoring package, like dissolved gas and oil. Dissolved gas and oil is seen as the #1 thing for power transformers, but it doesn't catch all failures. Some failures just evolve too quickly. And so we had a hypothesis that partial discharge detection for transformers of that type were critically important. And that's been proven in our experience now, that we can predict those failures better with partial discharge before you'll ever see a gas alarm go off, or the gas trend indicating to you that you have something wrong. I can't tell you, Bernie, how many times I used to have to work with the plant guys. I think I was telling you beforehand. And we would have transformers fail, and an hour after the failure, the gas alarm went off. Thanks for telling me. Yeah, that's really helpful. So gas is really good for slowly evolving failures, but not all failures happen that way. So we've got some cases where those were potentially preventable. I call them near catches instead of near misses. But we learned. We got to watch some fail. Not necessarily good, but we got to watch some fail, so we have a little better idea where the cliff is, so that we can do a better job of predicting them. We did prevent one at 345 kV. Interesting thing about age at time of failure, those were all brand new transformers. They weren't old ones. They were all bought with the packages installed when they were babies. They all failed in their infancy. So this is not just a play about old assets. Shipping damage on one, improper installation on another, that got past folks who inspected them before they were put in service. We've got one other little thing. We use 2 different gas and oil monitors. We use the single gas type of thing as the canary in the coal mine, and then we have a multi-gas monitor that cycles periodically, but it can be cycled on demand if the canary chirps. Last thing I'd like to say is that we think that we as an industry in the electric utility industry are lagging many other industries on this point, and we need to get here. So we're proud that we've committed ourselves to it. We've got a system that's working. I sometimes say the Asset Health Center will be wrong, but it will not be wrong in the wrong direction. It'll be wrong simply because we need to refine our knowledge and our experience and feed that all into the lessons learned and improvement of the algorithms. So having a vision and a commitment, similar to what Bernie said for the generation folks at Duke, we are moving that way in transmission. We would like to see many other transmission owners move in the same way, and that would help develop the market where people can make the more low cost, low or no maintenance, simple sensing that we need to detect the trouble that's going to lead to the failure or degradation of our equipment and impacts on customers and the public. So that's what I have.